Okay, so first of all, I would like to convey my gratitude to Shafi who contacted me, all the members of the Coding Wizard Club, Sushmita ma'am, whom I know for the past ages like 10, 12 years when I was in ITR. So I am an adult. I passed out from ITR in 2010. So before that, you should know what is my background. It was really a beautiful journey for me. I was the last batch. Our batch was the last batch of deputy at ITR. After that, it was what you call it now, SOA University. It was a beautiful time, so I learned a lot and tried to explore a bit more after that. So my profile says after my BTech, I joined TCS and worked there for around 7 months, but I wanted to always pursue my higher studies. So once I left this TCS, I joined at Indira Gandhi Center for Atomic Research for my PhD, and which comes under Department of Atomic Energy, Bhava Atomic Research Center, from where I completed my PhD on machine learning, which was the broader domain. So, and currently I am at Vellore Institute of Technology, Chennai campus as an assistant professor. Before that, I was working at SRM, and prior to that, I was working at ITR also. So the place where I was a student for 2 years, I was the faculty also. So that's a basic journey which I had till now, and still now I'm pursuing my career in the machine learning research. Okay, so briefly, I know. So is it all first years and second years mostly, right?
Sir, actually, some are third year also.
Okay. So if I'll take the average, it will be mostly first years and second years, right?
Yes, sir.
So I'll be starting off with full basics. I'll be sharing my screen and all those things I'll do. It will be mostly 30 to 35 minutes of interaction, which I have kept. I'll tell the basic flow of how to start. I'm assuming that none of you have any little idea about machine learning. So based on that platform, I'll start my talk. And it will be mostly an interaction. So once I finish, you can hold on to your thoughts. Probably at the end, I'll give you total 20 to 25 minutes in which you can ask whatever you can tell me, move to this slide, that side, everything I'll be doing. But I'll be completing it. So let me give me some time to complete the thing which I want. Okay, there will be doubts at middle. Mostly those doubts will be completing at the end. Will be covered at the end. So we'll go for that. And again, I'm saying I'll be starting from scratch. So let's see how it goes. So let me just share my screen. I hope my screen is visible.
Yes, sir, it is visible.
So at any point, if there is some network glitch around, please do let me know that, because I'll be going with the flow. So the topic which I have chosen is machine learning, the beginning. Okay, so we'll be totally starting from the scratch. So let's see what is machine learning. So we'll learn with examples. Okay, so this would be the content flow of this particular, I would say, a talk, not more of a class. We'll start with the introduction. We'll have some examples. In between, we'll go with the block view of machine learning. Wherever I write ML, it's machine learning to be shortened enough. Then we'll be going with the various categories. How do we create a model and its performance metrics of a machine learning model? What is k-fold cross-validation? Why it is important? What are the different tools which are available? And I'll give you a demo of a very small, like first project which I did on machine learning. I'll give a small demo how to do it. Okay. So mostly after that, you will have a little bit of idea about machine learning. Okay. So what do you see in this figure, guys? So there is a kid who's there, and you want to make that kid differentiate between an apple and a banana. So what you will do? Generally, what I have a daughter who is 3 years old, so I know the struggle of making kids understand what they want to, like what we want to. So what we'll do is we'll say show either there is two approach. Either you show the same apple 100 times or 200 times or 2000 times, and then say this is apple, and that kid will understand. Okay, we have something called red in color, and it is round shaped. It has this particular size, and once it gets familiar with that figure, it says okay. Next time when you show any apple variety, also bigger, smaller, whatever it is, you have small apples, you have big apples, then the kid will be able to say that okay, this is an apple. Okay, now similar with the case is banana. So if a banana, when you explain a kid like how does a banana look like, is this a banana or an apple? So how will the kid learn? You will show them 100 images, 100 varieties of bananas, small, big, round shape, long, all these varieties are there. Only after giving all this information, the kid would be able to know that okay, this is banana. Banana is yellow in color. The banana shape is something like this. The length is this much. The construction is this much. Anything which is yellow is not banana. You have to have all these features assigned to that particular image or object in order to say, in order the kid knows that it's a banana. Okay, so this is a basic example. Like when I say machine, machine is nothing but a system. Okay, we can assume the kid as a machine who is just new to this world, has no idea about what is an apple, what is a banana, all those things. So how do you make it learn? You'll get this is the process. You show them different photographs, everything with time, with different images. The kid would be able to know that okay, if something is red in color with this much, this shape and size, we call it as an apple. Okay, something is yellow. Everything which is red is not an apple. Okay, everything which is yellow is not a banana. So all these features the kid will learn with time. Okay, with learning. Okay, so this is one example where you can say okay, how do kids learn? So you can say this as a kid learning. Okay, now this is Shafin. I took his WhatsApp picture. Now Shafin, I have two
Yes,
figures over here. Okay, now
yes,
Shafin, let's just interact. Can you read any one of them?
no, sir.
You cannot read. Why can't you read it?
Because it's in Telugu, sir.
No, it's not in Telugu. It's not in Telugu. It is in some language which you do not understand, right? Now, if
Yes,
I
sir.
make you understand about these languages, you would be probably knowing which language is this. Then only it's not just the kid; it's about adults also. There are some things which the adults doesn't know. So there are things where you want to learn. Okay, as a kid also you learn, as an adult also you learn. So you need a rigorous learning and exposure where once I give those exposures to you, this is by the way Tamil in Tamil, because I'm in Tamil Nadu, so I'll definitely take. Though I don't know Tamil, but still I could find out. This is a Vanakkam in Tamil, whereas this is, I guess some Odia guys will be there. What is this, guys? Anyone can pick up? Unmute. Let's have fun. Anyone?
Namaskar.
Namaskar. Namaskar. So it's the Odia version of Vanakkam. Okay. So I am a Odia. Okay. So I know that. This is Namaskar. Okay. This I don't know. Just I assume this is Vanakkam. Okay. So now I suppose Shafi want to read this. Okay. What he'll do? I'll make him understand how Tamil works. What are the different letters in Tamil? How Odia works, what are the different structure of Odia. But at least, Shafi, looking at this, what do you see? This, when you talk about Odia, it's more of rounds than strikes. Whereas when you talk about Tamil, it has pointers also, something like this. It's some kind of features which at the first sight we can look into this. So once I make Shafin understand these languages, probably after 1 year, 1 month, 1 day, 1 hour, whatever it is, depending upon my input and his learning capability, he'll be able to differentiate between Tamil and Odia. Okay, so this is what again adult learning. Okay, now when we talk about machine learning, we'll see what are this. Now, what is this? Here, these two examples previously, we were talking about identifying. Okay, so this is proper identification. Is this or that? It's a cat or a dog. It's an animal, elephant or a tree, it's a tiger or a bear, whatever it is. This approach of differentiating is called as classification. Okay, we'll come to that. Now, what is this? This is one of the research which I had done. I should not say my students and myself, we have done. It was the prediction of COVID-19 active cases using some model. I'm not telling anyone. I don't want to focus on that. It was the COVID-19 prediction, active case prediction based on the time. This was 1st of like Jan 2020. This was March 2020. This was 5th May 2020, and so on. So based on that, we had to predict. Now, what is this? We are predicting. This is not a classification problem. We are not saying it's a cat or a dog or a jacket or a shoe or those things. What are we saying here? We are predicting the trend. Okay. So we are predicting the trend. Like if this is the case, what will happen after maybe 5th of May? May 2021. What will happen? This kind of problem is called as a regression problem. So we talked about two kinds of problem, that is called as classification problem and regression problem. Okay, CR, we generally call it as CR problem, classification problem or regression problem. So when you talk about machine learning, there are two varieties of problem. Mostly there are others also, but here we talk about two varieties of problem. That is, one is classification and one is regression. Okay, what is classification? Proper identification, cat, dog, object identification. But whereas regression is what? You are doing a predictive analysis. Example, stock market prediction. Example would be this COVID-19 prediction. Example, other example, maybe any kind of prediction. Suppose the housing property prediction. In last 10 years, this was the prediction of a particular area. What will happen in the next quarter? Something like that. So that is called as regression. Okay, I hope that by this time we are clear of what do I mean by classification and what do I mean by regression. Right? Now, what are the steps involved in any machine learning approach? Again, I'll be not going to the algorithms because those you can get it anywhere and everywhere. I want to focus on the steps, like how do you progress given a problem. Okay, now when you talk about any problem, classification or regression, the first thing which is important is this, sir, over here. What is this? This is called as data set. Now, what do I mean by data set? A set of data, as simple as that. Now, what do I mean by set of data? A collection of data. That means, suppose in this first example, we had over here, apple or banana. The problem here is I want to make this kid understand, differentiate between an apple and a banana. Okay, so over here I should have a data set which contains maybe 100 apple varieties, different styles of apples, and 100 banana varieties. I can collate these images and make it as one data set. This is what we call as data set. Having 200 images of the two, we call this as apple or bananas. It's called as classes. So as of now, we learned three things. I point out these things. First is what is classification. Second, what is regression. And the third thing, which is what are classes. Classes means in classification, the number of subclasses or number of participations which you are doing, that is called as classes. Okay, so here we have two classes. One is apple, the other one is, okay, so classes. Similarly, over here we are differentiating between a Tamil literature and a Odia literature, like writing styles. So this is one data set. You can have so many Tamil letters written over it, and you can take the images over here and make a data set out of that, along with the Odia data set. Okay. Now, what about this? Regression? Regression means again the historical data, whatever you are having, starting from whatever you're having. Okay, you can collect those information into a data set. So the main important, or like the most important part or segment of a machine learning algorithm or a machine learning model is data set. You should have a good data set. You cannot differentiate a apple and a banana having elephant and tigers images in that. Doesn't make sense, right? Example, you have a course like what do you say, data structure exam, and you are told that it will be a data structure, and when you go, boom, you get an operating system question. Doesn't make sense, right? So you'll be blank. So when you have a data set, it means a good data set, good solid data set. Okay. Now when we say data set, samples and labels. What do I mean by samples? Sample means features. Features means images. Okay. Suppose I have 10 images. Those are called as samples. Now what do I mean by labels? Over here in this total talk, I will not have any what do I say, definitions. I hate definitions. Okay, it will be real life examples. So what is label? To every sample or to every image, a name has to be attached to it if it's a classification problem. So we call it as, instead of name, we call it as labels. The data scientists or the machine learning people call it as labels. So image 1, what is it? Tiger. Image 2, what is it? Lion. Image 3, what is it? Tiger. Image 4, what is it? Lion. So sample, label, it should go hand in hand. Okay. Now the next thing is model training. You have the data set. What you do next? Train the model. Over here, it was this kid, maybe probably my daughter, Naika. Her name is Naika. So maybe I'm trying to teach her something. So she is the model. What is the data set over here? This is the data set, like all the images which I'll be having. And so when I try to train her, that is called as model training. Okay. Similarly over here, what is the data set over here? Everything which I'm having with respect to this Tamil and English, Odia writings. What is the model over here? It's your friend over here. And what do I do? I'm trying to make him learn something. So this is called as model training. Now, what is model testing? You know what is test, right? Your teacher teaches something, and you are asked some questions at the exam. You know what is that? Okay, I need not explain much on this. So this is these broad 3 steps when you go with machine learning. Okay, next. I hope this, as of now, it's clear. Like I hope. Let's see. We'll take it in the end. Any doubts? Okay. Now, when we have data set, the first thing was data set. Let's see what do I mean by training data set? What do I mean by testing data set? Example, you have your exam, data structure exam or operating system exam or whatever exam. Generally, if the question or the things which are taught in the class to make you understand, that is called as training data set, your courses. And when you talk about testing data set should be something which is new to the student, right? Okay, that generally doesn't happen in classes. We have a set of 10 questions, and out of that, some 2 questions will be coming in the exam. But here, the training data set and testing data set are 2 different things. I'll tell you the process, what happens. So just remember now, when I take a data set is broken into training and test data set. What I do with training data set? Train the system, train the model. What I do with testing data set? Test the model. That's it, as simple as that. Training, as the name suggests, train the model. Testing data set, test the model. Example, if I'll say, if I have an exam, I have 10 questions. Maybe in the class, I'll explain 8 of them. I'll explain everything about all the 8 of them. And in the exam, I'll ask for the other 2 which I have in my question bank. So I will not tell the other 2 in the class itself. So the point of testing is diluted, right? So this is what we tell about training and testing data set. Okay. Now this is the most important thing. Again, model view or like block view. As I said, the first step is creating a good data set. Once you have this good data set, what you do is you break this data set into training and testing. We have some percentage. It is always broken into 8:2 ratio, okay, or 80%, 20%. They call it 8:2 or 80%, 20%. So suppose I have 20 images or 20 samples. It is broken into, generally, you can defer this. it is broken into 80% and 20%. Okay. Now, what happens with this 80% data set? I have this data set. I feed this 80% data into the untrained model. Okay, untrained model. My daughter, your friend over here. Okay, untrained model. Now, what is this ML algorithm? ML algorithm is that algorithm or that approach which we use to make this untrained model a trained model. Okay. So what is necessary for an untrained model? A simple thing. What is necessary for this kid to understand? I need data and I need some technique like writing on the, showing it to her, writing on the slate, something like that. What do I do? What approach I do? Today I do take up 10 images. Tomorrow I'll take up next 10 images, something like that. Okay. So this is the basic untrained model you have. You feed in two things, that is the algorithm and the training data set. And once it does something, I'm not focusing on that now. It does something, it trains and trains and again and again. It's like I tell my daughter to all out from 1 to 10 in Odia. She takes A, do, E, T, Ni. But after that, she is fumble. Then I'll explain, no, it's not cha, it's 4, chari. Then she'll go ahead with chari, panch, and so on. So she'll fumble, she'll learn again, I'll start again. So that's the process. It is not a single set process. It's a process which goes again and again. It takes time. Okay, this takes time. Now, once this training is done, I get this trained model. I know, okay, my daughter is ready for the exam, or you are ready for the exam. The exam date appears. You now feed the testing data set. Okay, the remaining testing data sets. See over here, it's totally hidden from the trained model initially. It is totally hidden. It's not shown to it. Now, you feed this testing data set into the trained model to see the performance or the accuracy. If it's good enough, if it gives all correct results, happy. If it gets 80% accuracy, happy. But if it gets 50%, we need to think, what happens when you fail? No. What happens when you get a backlog? You have to go back again. This teacher will be teaching you the same thing with some different approach. The teacher will be thinking, why did this student fail? So they'll be having some different approach, and you again start learning, and you get again another new trained model with the testing data set, and you get the accuracy. So this is a process. When you talk about ML block view, it's mostly this process which is more important. Okay. Now, what extra can we do when we talk about research? If this is the process, where do the research happen? The research happen in these two areas. Number one is this. Number two is this. These two are the area where the research happens. When I say feature extraction, what do I mean? What are features? What is that feature of the apple which I talked about? If the kid is not able to understand the color red, how will the kid understand what it's an apple? If the kid is not able to, if we are not able to make the kid understand, okay, apple is red in color, the kid will never understand that's an apple. Similarly, with a banana, if you are not making the kid understand there is a color called yellow, the kid will never understand it's a banana. So this is the most important step whenever you talk about the data set. Feature extraction. How do you get out the important, the necessary feature which distinguishes between a distinguishes between a banana and an apple? So this is the research topic. How efficiently, how fluently, how graciously you are taking out these features so that the training data set becomes more valid enough. The testing data set also becomes valid enough. This is one area, gray area, not gray area, lot of research is happening over here. Another one is the algorithm. Today I use Blackboard. Next time I'll use maybe some PowerPoints. The third time, if the student is failing, maybe I'll take him to him or her to a proper industry or a real life examples. So that is where the ML algorithm comes into picture. So these are the two things where you see the importance of machine learning algorithm. Am I audible, guys?
Yes, sir.
Yes, sir.
Yeah.
Sir, sorry to interrupt you, sir. Like, there is one of the member who is having a doubt.
Yeah. Tell me.
Sir, he asked like, should be there storage of training data sets in order to develop the algorithm?
Storage of training data set.
Yes, sir. Jyotri Aditya is asking that question.
Yes, training data set is a storage. Well, I'm not, maybe I'm not able to get it. Obviously, you'll store these data sets are stored so that it will be reused. If you think the accuracy is not good enough, it will be obviously stored and will be reused again. Maybe you can increase the data set capacity. If this time you have 100 images, next time you might increase the data set, because whenever you talk about machine learning algorithms are data hungry processes. They need data, they need images, they need samples. Without that, it's difficult for them to understand or do that feature extraction. So yes, the storage is mandatory for any kind of data set. I hope I understood it correctly. Yes, Jyoti, is it what you wanted to or anything else?
Yes, sir. He replied with yes. Thank you, sir.
Okay. So this is the basic block diagram, and I said the major important things which goes on in the research area is basically the feature extraction and the machine learning algorithms. Okay. So what next? The categories. Okay. So when you talk about ML algorithms categories, we are basically having three categories, broadly divided into three categories. One is a supervised learning, another one is unsupervised learning, and another one is reinforcement learning. I'll just give you the basic difference between these three. When you talk about supervised learning, means the data set has samples and labels. Means the pre-hand itself, you know that this image is of a lion, this image is of a tiger, this image is of a bear. So in pre-hand itself, you know the outputs. Okay, so that is supervised when you know. Unsupervised means you do not know. You have a chunk of data where you don't know what are the labels. How you make the machine learn out of that. That is called as unsupervised. And what is reinforcement learning? Reinforcement learning is the simple way is how do a kid start walking? It starts walking, it falls down, it learns, okay, this is a hurdle, I should not jump over that, I should bypass that. So next time he sees that, he'll bypass that. Okay, then it's like that. You learn from your mistakes and keep on improving. That is called as reinforcement learning. Okay, and when we talk about supervised learning, there are two varieties which I've already said: classification and regression. Classification, fraud detection. These are some of the examples or the domain where these approaches are used. Fraud detection, email spam detection, diagnostic, image classification. Means majority of works are being done on this. You will find everywhere these things being done. Okay, the best example, you might have the spam folders in your Gmail if you're having, right? So this uses a classification approach, seeing some words present in this. Lottery, money, if you see, automatically it will go to your spam. Regression, as I said, risk assessment, score prediction, any kind of predictive measures in future foresight, what is happening, that is called as regression. Dimensionality reduction, basically what do I mean by dimensionality reduction? Okay, these are big terms, I do not want to focus on much on that, but just imagine you have 200 features of a particular sample. It's very difficult for a person to, like, if I have a data structure course where I talk about I make a class of 200 hours, it's difficult. So from that you will break down into the important topics of data structure, and then only you focus on those subjects. That is called as dimensionality reduction, reducing the number of features. Clustering is again good, like you have in your class itself, you will have groups, right? The 9 pointers group, the 8 pointers group, the bunking group, the sutta group, the the biryani group. So you cluster that. That is called as clustering. So that's mostly how unsupervised learning works. And reinforcement, as I said, with how a robot learns. With time, with defaults, it learns its mistakes. Okay. Now, performance matrices. Again, I'll just go over it. Now, how do you decide on how if a model is good or bad? These are the basic measures when you go with performance matrices. One is the classification. You have precision, recall. Accuracy is the important part. We can put it over here. The standout over here. Accuracy means how many correctly classified. Correct divided by total. Simple. How many apple and how many bananas was correctly classified divided by the total number of apple bananas. Okay. In regression, you mostly talk about mean square errors, average errors, R squares. It's basically where was it actually and where did you predict? So what is the difference among them? That is regression. What about unsupervised? You talk about RAND index and mutual information. Again, it is because you do not know the labels. So how different are each and every sample among them? So that is called as that is the feature matrix which determines the unsupervised model's performance. And the last one, others, any other models, you have this heuristic method. This is very minimal. Most of people do not use this, but depending upon the usage. Okay. What is k-fold cross validation again? Why do I need this? This is again another story. It's like one go. If can I say a person is like if I teach 1 year to one student data structure, I cannot say myself as I am pro in data structure. Right? If I do it second year, okay, I have little bit confident. If I do it the third year, then I am confident. So this is an approach which sees the robustness of a model. If the model performs good enough for 3, 4, 5 times, we say this process is called as cross validation, and this approach is used to check the performance of a classifier. Okay, so like how robust is the classifier? So that's how you decide. This k-fold cross validation is a approach to check the robustness of the classifier or any machine learning kind of model. Okay, so and the tools which are generally used for any machine learning, you must be eager to know how do I go about, how do I work on this. So basically these are the tools which you use. My personal favorite is Google Colab, because everything is now internet, and you almost find all the packages over here. So I started off with Python and Jupyter Notebook, but I found Google Colab much easier. This is one platform which you can use for your daily machine learning approaches and all. You can learn a lot. The next one would be Jupyter Notebook. I'm going from down to top. Okay. So next is Jupyter Notebook. It's a standalone software which you can install in your system and then work out on it. Then you have this Google Cloud. The spelling is wrong. Sorry, guys. So AutoML. AutoML means it's kind of a system which makes life easy. It's like your parents also who are not familiar with Android, and my grandfather also something like that may be using phones. That's how Google Cloud Machine AutoML works. You just feed in the data, it automatically does the machine learning part and gives you the output. Okay, this is costly because it does that much work, but yes, it's there. You have this PyTorch. PyTorch is a package which is used for major feature extraction kind of work in machine learning. Okay, you might have heard of these terms. Just listen to these terms. As of now, you won't understand anything of this, but if you are working on machine learning, you'll definitely come across these terms. Vika is a software which is used for such kind of machine learning approaches. It's again to make your life easier. It's just a drag and drop kind of stuff. You can explore this. TensorFlow is a package which is used to carry out like major functionalities of any machine learning algorithms. Okay, so that's like a platform over which other libraries also sits. Scikit-learn is again another package which is used in Google Colab. It is used in Jupyter or Notebook, everywhere, to make life easy. As of now, to make life easy, these things are there. Okay. So as of now, this was what I wanted to. But before ending, I would like to show you one demo of a small project which I had done at the beginning itself. So I would like to show it so that you get a hands-on, like what is he saying? Is it actually real? So I had actually done this. Let's do it from the scratch. Like I'll be doing this for you guys. Is my screen visible? Is my Google Colab visible?
Yes, sir. It's visible.
Yeah, so this is the Google Colab which I'm talking about. This is free, so you can use it. You can search out how you can use Google Colab and all those things. But I'll just show the code. I'll not explain the code. Just get a feel like how it works. Okay. So then you can explore on this part again. Okay. But the important part is you need internet for this. Okay. So that is important. Without that, it won't work. Okay. So this is getting mentioned. This code is basically for digit recognition using a webcam. That means there is a data set which is called as MNIST data set, okay, which has all the different styles of handwritten data digits. Like it has a collection of 60,000 handwritten digits from 0 to 9. Okay, so it has 60,000 images of different styles of digits written. Okay, and we'll be using a webcam to use this model. Okay, I'm not working on the like the performance, but I'm just seeing a working model I want to show you guys. Okay, so these are some of the packages which I am installing for this particular job, and this is the Keras dataset which will be using Keras package to download the MNIST dataset into training and test, which we talked about training dataset. So I load the dataset into training and test dataset. Okay, what is X and Y? X are the samples, Y is the labels. Okay, again, if you're not understanding also, it's fine, no issues. Now here you see you have training data shape is 60,000. That means in the training sample you have 60,000 training data set. You have 60,000 images of each of size 28 cross 28 pixels. Okay, and the testing data set has 10,000 samples, each of size 28 plus 28. Okay, so this was the so you had the training data set and sorry, the data set, and that was divided into training data set and test data set. Okay. Now this is the shape, like how does this train data set look like? Zeros and one, because it was black and white images. So based on that, the zeros, and wherever it was finding black, it is 0, and wherever it is finding the white, it gives a number to it based on the grayscale. Okay, so this was the data set. Now, if I'm just showing you the first 5 samples. So that is 50419. Okay. Now, how does this first 5 sample look like? Let's see. Okay, so this is C. So 5, the first 5 looks like this. Then the second image looks like this, 0. And then you have this 4. Then this was 1. Someone has written 1 like this. And this is 9. Okay, these are the 5 out of the 60,000 training samples. Now, if I want to train it, this is the normalization. Again, I'm not going to explain why are we going with normalization and all. But these are the steps which you need to do in order to have a uniformity of the images. Okay, so I need to normalize that, and this is my model. Okay, this is my machine learning model which I'm using for making the system untrained model which we talk about. This is the model which is untrained. Okay, now this is the training going on. Okay, so it runs for 3 cycles, or we call it as epochs. So 3 cycles, and see at each cycle it is showing the loss and the accuracy. So initially the accuracy is 86 or 0.86. In the second iteration, the accuracy is 0.96. Obviously, it should increase. If it is increasing, it is good. If the same thing I'll teach you second time, I think you'll understand much better. The third time if I teach, you'll understand much better than the previous. So that's why your increase of this accuracy is good. Okay, now let's go. I'm not showing all these things. Probability, I'm not showing. This is not needed. This is also not needed. Loss, okay, that is also not needed. This is the prediction. Okay, Now, once this prediction is done, this is the test output which is showing, and it says the 7 was the actual output, and the figure which you got was 7. Okay. Now the interesting part. I want to take a picture. Okay. So I want to use my a webcam to take a picture, and the model will detect if the what is the number, if it's correct or wrong or not. Okay. So this is the code for taking a picture from your webcam. So I'll use this. So this is the webcam which is running on. I hope you can see me over here. Let me open. I'm not having paper, so I'm just writing it here. Okay, guys. What do you see here? What do you see?
2, sir.
2. So let's see if the system checks it could classify it as 2 or not. Okay, let's see. So I take a picture. Now this picture is saved. Now it should do some pre-processing, feature extraction, whatever it does, and puts it into the system model which I have. Okay. See the feature extraction. This is the black and white image transformation which has happened, and this is some feature extraction which happened. And you see over here the system is saying it is 0. Okay. Why? Because you see the probability distribution. It starts with 3, 0.3, 0.00 for 1, 0.21 for 2, 0.11 for 3. So whosoever is having the highest probability, it is predicting that the model is that particular number. So 0.33 was the highest one out among these all 9 or all 10. So it said it is 0. Yes, this is not a good model. Why? Because it's not giving me the correct answer. But this was just a working thing which I wanted to show. If you increase the epochs over here, the number of iterations, if you want to, if it increases over here, it may be probably 99%, it might give you a good result. For that, you need to run this model for more number of times. So that needs some time factor also, because this class has a small restrictions of time. I have just ran it for 3 times just to show the working model. Okay, let's try it for one more time. Okay, let's try it. I don't know if it might give a good correct result, or maybe it might give a wrong result. Okay, let's try it one time. I'll just rub it again and write 2 again. This time it's saying 6. Again, it needs a lot of running also. Even if 96% is not enough for it to make it a good prediction. Again, my thing over here, my objective over here was not to give you the best accuracy and all. The thing was, if you run it for more number of reports, if you have a good amount of data set, if the feature extraction is good, then it will detect. Okay. So this was something which I wanted to show it to you with this much time and all the resources which I had. Anyone having any doubts or clarification, I would love to hear them out. As of now, I am done with my presentation. If anyone wants to ask anything, please feel free to ask.
Guys, is there anyone who wants to?
So I had to ask one thing,
Yeah.
that the stronger our algorithm will be, the lesser number of times we will have to take tests, means we have to train it, right?
Yes.
Is it that the stronger the algorithm, lesser number of times you will
Yes.
train it,
Yes.
and
You can assume.
finally it will determine that how better your algorithm is for machine learning,
Yes. Yes.
right?
Yes. Again, there is a two things, as I said, there are two parts to it. One is the feature extraction. If the feature extraction is good, a good enough model is also would give better result. Okay, if the feature extraction is not good, you need a harder model to give a better accuracy. So it's kind of two-way process. It's like a handshaking between two. If both of them are good enough, you'll get a very good model. If one of them is not good, one of them is very good, still you cannot guarantee that accuracy. So it's like two things which works very much hand in hand. That is, one is the feature extraction, and second one is the algorithm.
Okay, sir.
Hello, sir.
Yeah.
Sir, you gave an example just like how a child is going to recognize between an apple and banana. So if I'm showing two bananas, that is a real banana and a toy banana. So the child is going to recognize both as banana. So how the ML is working to recognize it that the toy banana is not a real banana.
Even an adult will not able to recognize a toy banana and real banana without actually touching it. Okay, so there are some things where the features also come into picture. You cannot, if it is too far ahead in front of your eyes, whatever your eye perceives, whatever those features only would be extracted, right? Can you differentiate if there is some person, I'll keep two bananas, a toy and a real one, like maybe 10 meter ahead. Can you, from that far, can you see it? Can you recognize it? No, it's
Yes,
not possible.
just like the texture or the color
That's
construction
what.
maybe.
That's what.
Maybe
If the feature extraction is that perfect, you are able to extract that particular good amount of features that, okay, this is the toy banana feature which will not have that smoothness and which will have that smoothness compared to a real banana. Yes, well and good. If your feature extraction is that perfect. If it is not, probably even the adult can confuse between a toy banana and a real banana until and unless you actually touch it.
so sir, can you suggest some good resource to start machine learning?
Resource, as I said, material resource.
Yes, something like something like just like that to start machine learning. That a guy knows something what is machine learning, just basic kinds of thing, and how he can proceed. That kind of resources.
See, again, you will not find everything at one particular place. You have to explore a lot. So there are other Stanford courses. Also, when I started this, Andrew Ng is like we machine learners feel like he's the god, but you won't understand at the beginning. It's a little bit too much for you to swallow it out because those terms and all will be very difficult. So what I would say is just as of now, you people are always browsing across YouTube and all. Just go through random projects. Just see, how do I do this? How do I do that? From that you learn a lot. I will not suggest any particular material which would help you because there are so many and so vastly distributed. So really, I cannot help you in that. But if you just initial out of curiosity, you can go to YouTube itself. That is the best platform which you can get. You get hands-on sessions. You try it out what they are doing hands-on, and then you by learning by doing itself the best way of understanding a particular concept.
Excuse me, sir. Sir, I have a question. Sir, if we give means some command or means something to the means if we write something in ML, but the two lines are contradicting, then at that time what will the means program will do? Means sir, like sir, if we tell a children that see the apple is red and you should when you get it you should eat it, but then again we will tell red color means danger, and when you see it you should go away. So at that time, what will the means a person or that program will do?
That's right. The problem should be very defined. You cannot mix two problems because these are machines, right? When the complexity increases, the performance would obviously decrease. Okay, Okay, so you should have your problems fixed. If your machine learning, you're making a model which does this task, you cannot overload that model with other tasks also. If the model, that's what I said. If you have a data set or a model which differentiates a cat and a dog, that time you cannot give an apple to it and say what is it. Obviously, it will give some wrong results and absurd results. So in that case, you should be very careful enough in selecting your what do I say, the objective of the particular work which you are doing. So you cannot mix and match everything. In a data structure class, I cannot ask questions on operating system, though operating system uses some kind of data structures, isn't it? So those third years and all, they would know. Like when you talk about operating system, that is also a kind of data structure where you will be having schedulings and all those stuff. But you cannot mix and match, because again, these are just new learners. Once they learn a lot, you can force extra thing. But again, at the initial stages, keep your problem defined, pretty defined. Do not make it totally like a very an abstract. Make it defined.
So, in order to learn machine learning, which part of probability we should focus more on? Because I have heard it from someone that you need to make your probability and statistics very strong in order to pursue machine learning. So,
I am
we
very
have
bad.
learned probability till 12th, but which all extra parts we should learn about
See,
probability so that we can pursue machine learning?
as I said, the best thing to learn is learning by doing. I myself very bad at mathematics. I'm not at all good at mathematics, but still I could manage. At times when I get problems, I have these hiccups. I'll refer it. If you think you need some more efforts, you give some more efforts to this. But again, probability is, you don't have that much probability as you have in your 12th. It's just minimal probability which you will be using. As and when it comes, you go ahead and explore it. I won't say you start learning probability to start with machine learning. That's not needed at all.
Okay, sir.
Any other question? Is there any other question in the chat box?
Sir, does hardware that we use also play an important role?
Depending, for machine learning models, when you're testing, you're asking that.
Yes, sir. Means, sir, like you have told that, means, sir, see, sir, means, I want to ask that, sir, sir, if you use a better camera, then the results can be more accurate.
Yes, yes,
Sir,
obviously.
that way.
Obviously, yes, yes. It is totally dependent on the task or the problem which you have defined. Okay, so if you have a problem where the camera is not needed, then fine, well and good. Again, if this problem was not just taking a webcam and taking pictures, it was just some images which is there in the Google in internet, reading from that, maybe the answer would be different. So, but for models perspective, learning perspective, if you are working on Google Colab, it runs on internet. You need a good internet for that. If you are working on Jupyter Notebook, it does not need a good internet. You need a proper RAM for that, so that the training process is reduced. That's the only, the training time is reduced. That's the only hardware effect which you can have. Again, having said that, I would definitely say it varies from problem to problem.
Sir,
Yeah.
along with probability, what part of studies we need to learn for machine learning?
Linear algebra. That is like bread and butter for machine learning, guys. Like you should be strong in matrices, you should be strong in eigenvalues, eigenvectors, what is it called, distribution functions, linear algebra. These things would be your bread and butter. You should not fumble in these things. You should know what are these things, what are basis functions, what are what do I say, Gaussian distribution, what is normal distribution. All these things you should be in your tip of your tongue. That's it.
Excuse me, sir.
Yes, Akash.
Sir, it would be great if you, sir, explain a little about decision tree pruning, sir. Actually, I am not that great in that. If you would not mind.
Decision tree pruning. This is
Yes.
beginning, guys. Others are also there. I cannot be so specific into explaining like what Akash is talking about. Decision tree is a classifier problem where it creates based on the like problem. It creates tree, and at each level it takes a decision as to what kind of where does the tree move forward. So it's a totally algorithm based, which is not, I do not want to focus it on because people will go crazy over here if I go and focus on that. So as of now, I can just say that decision tree is one algorithm where based on the current status of the tree, it decides on to the growth of the tree, which way it should grow, either left or right. Based on that, it will decide. As of now, you take that much, you'll find a lot of stuffs over the net, but do not bother too much over your head.
Yeah, so actually I'm from third year, so that's
Okay, that's why I presume that only because decision tree. So when I talk about algorithms, the decision tree is one of the supervised machine learning algorithms.
yes.
Where the samples, you have the labels, and based on that you have to make a prediction on to which class does it belong to. Okay, so decision tree are good with multi-class classification. If you know what is multi-class classification, they are good with multi-class classification, whereas if you talk about a normal SVM or a KNN classifier, those are basically a binary classifier instead of multi-class. They do not perform good at multi-class classification because it has tree structure. It gives you that freedom onto going and classifying the multi-classes instead of the other SVM or linear regression, sorry, logistic regression, linear regression, and all those.
Sir, like my model is not so much accurate, sir. With this decision tree, I can increase the accuracy and reduce the complexity.
Again, as I said, it's about two things which matters. Either you change the model or either you have a good feature extraction, because the feature extraction is also a part. You might have the best model, but if the feature extraction is not done properly, even the best of the model will fail to give you good accuracies. So it has to be a both way work. It has to you have to improve the feature extraction approaches also, and in that case you have to increase the model like algorithm also.
Okay, sir, like this is basically based on heuristic method, I think. It is
Okay.
similar to that heuristic.
Maybe I have to go through a little bit more with this much information. Is difficult to comment on what you should do. It varies varies from problem to problem, and again, having said that, also I cannot guarantee. That's what the problem with machine learning is. You cannot guarantee which algorithm gives you the best result for what problem. So you have to always do a comparative study in order to get the best model for a particular problem.
Okay, sir, got it. Thank you, sir.
Is there anyone more? I think they have done. Yeah, Rituraj.
Sir, how basically the deep learning is set off with a machine learning algorithm?
Sorry, deep learning.
Sir, how deep learning set off with machine learning?
How deep learning is set up with machine learning?
Yes, sir, like the algorithm which we use in ML.
No, it's deep learning is a subclass of machine learning. So when you talk about deep learning, it's mostly when you talk about images. Okay, but when you talk about machine learning, it's about images. It's about samples. It's about Excel sheet. That is also machine learning. Okay, so when you talk about deep learning, it's mostly when you focus effectively and most likely on images. That is called as deep learning. And in the Other difference in deep learning and machine learning is machine learning has feature extraction and learning separate. You have to separately do the feature extraction and you have to do separately the machine learning algorithm. But when you talk about deep learning approaches, the feature extraction and the learning is done combined together. So other than that, both are same. It's like both. It's again, it's a subcategory of machine. Deep learning is a subcategory of machine learning.
Thank you, sir.
Anyone else? I think they have done, sir.
Okay, then it was my pleasure. If anyone wants to do any kind of research or any inputs, if I want, you can contact Shafin. He'll be forwarding. Maybe we can do some work, because I am currently working on some of the problems based on deep learning and machine learning. I have so my proposals are there, and my students are working on COVID-19 detections. Also, some of my students are working on poultry farming, smart poultry farming, and some are working on smart agriculture, that aspect also. So these are some of the features we are working on. So let's see what happens. Thank you, guys.
Yes.
For,
Yes, thanks.
Thank you, sir, for giving such a nice time, sir.
Okay.
my pleasure. My pleasure.
Thank you so much, sir.
Thank you.
Thank you so much, sir.
Thank you, sir.
Thank you.